So the question 1775, it says that the wheel has a mass of 25 kg and a radius of gyration kb 0.15 meters. It is originally spinning at omega 40 radian per second, which is the angular velocity. And if it's placed on the ground, for which the coefficient kinetic friction is 0.5, and we have to determine the time required for the motion to stop, and also the horizontal and vertical components of reaction which the pin A over here exerts on AB during this time, and we neglect the mass of AB. So we have the wheel, it has different dimensions given to us from pin A and this AB connection over here, and then there's a point C which is on the ground, and the radius of the wheel is 0.2 meters. So to start our problem, we draw a diagram over here in which there will be a vertical force of reaction force of NC, and there will be a 0.5 NC in horizontal direction due to friction, and it is towards the right side because it will go against the motion of the angular velocity, which is clockwise, so it will be in the opposite direction to that. And then there will be a force FAB, so we break it down into its components 0.3 and 0.4 because we knew the dimensions of the AB handle, which has the horizontal distance of 0.4 and a vertical of 0.3, and we know the angular velocity, which is 40 radian per second in the clockwise direction. So first we do for the summation of the horizontal forces, which is equal to MAG, and the acceleration in the horizontal direction. We know that acceleration will be 0 in the horizontal direction, so the forces in the horizontal direction are 0.5 NC minus 0.4 divided by 0.5 FAB, and FAB is in the left direction, the horizontal component, so it's negative. So we simplify the equation and we make NC as a subject, which is 0.4 over 0.25 FAB. So this is the equation 1, and then we do the same for the vertical forces. NC plus 0.3 divided by 0.5 FAB, both are in the upward direction, so they are positive, and the mg force, the weight of the wheel, it's in the negative because of the downward direction. So we substitute the equation 1 in equation 2, and we get FAB, which is 111.477, and we get NC, the normal reaction force at C, which is 178.36 newtons. And then we find the horizontal and vertical components of FAB because we knew from the triangle, and so for the horizontal component we multiply by 0.4 over 0.5, we get 89.2, and for vertical is 0.3 divided by 0.5 multiplied by FAB, which is 66.9 newtons. So these are the vertical and horizontal components of pin A, which are on the AB. And then we use third equation for the movement. We consider that counterclockwise is positive, which is equal to the inertia at B multiplied by the angular acceleration, and it is a thin ring in IZZ direction. So we use the formula mk square b multiplied by angular acceleration over here, and in the summation of moments we only have nc, which is 0.5 nc multiplied by 0.2, which is the horizontal force over here. We cannot take nc or mg because they are in line with the center of the wheel and they are in the vertical direction, so we need a horizontal perpendicular distance which is 0, so that's why you cannot take nc or mg in this equation. And nc, as it is moving in a horizontal direction and it has a perpendicular direction from b, so we only take that, which is the radius of the wheel, 0.2, and we use kb, which is radius of gyration in inertia. We put in the values and we get angular acceleration minus 31.71 radian per second square, because as we know that the angular velocity is in the clockwise direction, so angular acceleration is also in the clockwise direction, which is negative. And then we use the equation, which is the angular velocity is equal to initial angular velocity plus the angular acceleration multiplied by time. L was given that it comes to rest, which means that angular velocity becomes 0, and we knew the initial, which was 40, and we add that with the angular acceleration multiplied by time, and the time taken is 1.26, and also it's negative angular acceleration because it's decreasing, which is deceleration in other words.